Hello, dear students. In this video, we are going to see about lex. What does lex means? Lexical analyzer generator. So where it is used means the first phase of the compiler is lexical analyzer. So in the lexical, what is the job of the lexical analyzer? It will read the input program and then it will match the streams of characters and to regular expression. So if it is matching, then it is considered it as a lexeme. And then the lexeme can be categorized to tokens. So the tokens can be an operator, or it can be a identifier, or it can be a keyword or a delimiter, like this. So the lexical analyzer's job is to do the tokenization. So to help this tokenization, we have a tool called Lex. So what is the expansion of Lex is lexical analyzer generator. So the acronym of that is Lex. And now this is the process how the Lex will be working. So whenever we write any programming language, it has an extension. For example, Java means the extension of a .java file is .java. Similarly, C means .c, right? So Python means .py. So similarly here for Lex program, the extension of Lex program is .l. And when the Lex tool itself has a Lex compiler, so when you write a Lex program, that Lex program will be given inside the Lex compiler. When it compiles, it will give the answer back as lex.yy.c, which means a C program. So because you can see the extension is .c. So when this C program is now given into a C compiler, we'll get an as usual output in the standard output file, that is a.out file. So now to this standard executable file, when you give an input stream, it will now do the job of sequencing of tokenization. So we'll get sequence of token as the output. So this is how a Lex program will be working. So what is the use? Okay, so now before we go, so this is what I have explained. So all the Lex program will be with the extension .l, and then when you give this to the compiler, you will get to the Lex compiler, you will get a C program, and then you will give it to the C compiler, you will get an a.out, and in the a.out, when you give input stream, you will get the tokenization. And what is YYL val is? So these are some of the terminologies used inside the Lex program. So YYL val, it's a global variable which is shared by the lexical analyzer and the parser. So to return the name and its attribute value of the token. So now let's discuss about some other terminologies. What is YY text? So this YY text is will hold the input characters which is matching to the pattern. So whenever it is a sequence of input string is matching to a pattern, we call it as lexeme. So that is present in YY text. And what is YY lex is the entry point of your lex program is YY lex. You know the entry point of the Java is main function. Similarly, the entry point of the lex program is YY lex. And some other terminologies present here is YYN. So YY in, for example, if you are having input or input stream in a file, YY in a file, so YY in will be pointing to that file. And YYLex, already I have told you, it's the entry point of your Lex program. And then what is YY text? As I have already told you, YY text means it holds the input characters, that is the lexeme. And YYLN will hold the length of the lexeme. YYL val will be holding the value of the token. And YY val is a local variable. YYLVAL means it carries the value of the token. And YYVAL means it carries the local variable. And YYout like YY in, YY out is the pointer to the output stream. And then YY wrap means when you reach the end of the file, it is called. And then YY more will help you to return the next token. And YY less of K means it will help you to return the first K characters in the YY text. Hope you remember what is there in the YY text. YY text will be carrying the input characters, which means the lexemes. So from the lexeme, it will return you the K characters. And YY parse. What is YY parse? Will help you to construct a parse tree of the lexeme. So these are the sum of the predefined functions and variables which is present inside the lex program. Now let us discuss about the structure of a lex program. So for example, if you take a C program or a Java program, it has a structure. For example, if you want to write a Java program, first you have the header file, right? Import java.util.star like that. Followed by have a class. Inside the class, you should have a main function. So similarly, in Lex program, the structure of the Lex program is this. This is how we write the Lex program. So first part of the Lex program is declaration. After you finish the declaration, we'll discuss what is declaration in short. Shortly. So after declaration, you have to put 2% symbol. So this will help you to like separate declaration from the next part. Followed by the percentage, you have to write the translation rules. So, and after you finish the translation rule, again 2% symbol, followed by you have to write the auxiliary functions. So this is the way we write the Lex program. Okay. So as I have already told, Lex program will be having an extension with .l. First, this .l file will be given to the Lex compiler, and the Lex compiler will give .c file that is called lex.yy.c. And when you give it to the C compiler, you will get the output here in the file a./a.o. So now we know the Lex program have three parts, right? Declaration, translation rule, and auxiliary functions. Declarations means what? Just, for example, in Java, how will you declare a variable integer? Age equal to 0. Integer 0, CGPA equal to 0.0. So this is how we declare the variables and we assign some values to it. So those kinds of declaration will be done in this declaration part. The next part is auxiliary rules. So how does an auxiliary rules look like? So this is the way the this is the way the translation rules look like. So first you have to write the pattern followed by its corresponding action. So whenever you are matching some pattern, what should be the action taken? So that action can be written in C. And the pattern can be, for example, if I want to match the variable, so I have to write the pattern for the variable. Or if I want to match all the positive numbers, I'll write the pattern, which means the regular expression. And if I am matching all the positive numbers, what should be the action I have to do can be written inside this as a C expression. Now let us now let us write a Lex program to count the number of positive numbers, negative numbers, positive fractions, and negative fractions. So as I have told already, this is a Lex program. Okay, it's a Lex program. So as I told you, this Lex program has three parts. First is declaration. So this part is called declarations. So what is there in the declaration? As I told you, whatever the variables you're going to use here can be declared. And if your declaration is a C program, then you have to start with percentage curly brace and then close with percentage close curly brace. So inside this you have to do. So as I told you, for example, if I want to do the declaration age equal to 0 and then indeed the float CGPA equal to 0.0. So likewise, whatever declaration you want to do, you have to write. If it is a C declaration, put it inside the symbol. So as this program is to count the number of positive numbers, negative numbers, positive fractions, negative fractions. So 4 things I have to count, right? So I have declared 4 variables. Since I have only the counts, it's an integer value. So I said integer, positive number, initially it is 0. And then integer, negative number, it is 0. Integer, positive fraction, 0. Integer, negative fraction, 0. Likewise, I have taken 4 variables. You can give any name to this. This is just a variable. Since it is a C code, I have written inside percentage open curly brace and percentage close curly brace. Followed by this, I have also did a declaration stating if it is 0 to 9, for example, if it is 0 to 9, which means any numbers between this. So which is a single digit. So it can be 1 or 5 or a 7 or a 9, whatever it may be. So for this, I'm going to give a name for it. I'm going to name it as digit. So this is also a declaration. Since it is not a C code, I have written it outside the percentage open curly brace and percentage close curly brace. So that's about the declaration. So as you see in the syntax, after you finish the declaration, you have to put two percentage symbol. So that is what here it is. Two percentage symbol are there. After declaration, what is the next part we have given? Translation rule. So how does translation rule looks like? You have to write the pattern followed by the corresponding actions. So now we have to write pattern for four things. Why? Because we have to count four things. What are the four things we have to count? First, you have to count the positive number. Then you have to count the negative number, positive fractions and negative fractions, right? So I have to write four patterns to identify all these four things. So first let us write the pattern for finding the positive number. So you know how the positive numbers look like. I can write plus 54. This is also positive number, simply 54. So both are positive numbers only. So I have to write a pattern or a regular expression which should match both of them. Okay. So first I want a plus. So I am writing plus. But you know, in regular expression, plus has a special meaning. What is the special meaning of plus in regular expression is one or more number of times. But this plus doesn't mention that. It normally mentions a plus sign used in the number. So I have to escape this plus from the meaning of the regular expression. So I have to put a backslash. For example, you know backslash n is an escape sequence for the new line. And backslash t is the escape sequence for tab, which you know from other programming language like Java. So n has a normal meaning, but to escape from that, we put backslash n. Similarly, t has a normal, it's an alphabet. But if I want to escape from the alphabet, I have to put slash t. Similarly, plus has a meaning in a regular expression. So to escape from that and to say this plus is a normal plus in a number, I put escapes. So followed by that, this plus, how many times this plus will be coming? So this plus will be coming either one time or 0 times. See here it is present one time. We will not put plus 54, right? So plus should be written only once. So question mark. Question mark says what? 0 or one time. So that is why it is written as question mark. So plus can be repeated 0, it can present or it cannot be also there. It's an optional. So the question mark. So followed by the question mark, what should be their digits? It can be any number of digits, right? So already we have said 0 to 9 can be a digit. So instead of saying 0 to 9, I have already given a name for it, right? So I can say it is digit. So what does digit mention? 0 to 9. And this digit can be any number. For example, I can say 5, 7, 8, 1, 2, 4. So any numbers, any number of digits can be there in the number. So this can be one or more number of times. As I said, plus means one or more number of times. So if I want to say it is a number, at least one number should be there, right? Then only I can say it is a positive number. So I said this. So this is what represents here. So if it is finding a pattern like this, what is the corresponding action to be done? I have written here. So if this kind of pattern is there, you could able to match means immediately increment the variable positive number. So it is incremented here. And then what is the next thing I have to find? Next pattern to be found out is I have to find the negative numbers. So how will you write a negative number? So negative number always have minus sign in it. So you cannot skip this minus, right? So minus sign is very, very important. And so I am putting minus. Why I don't want to put backslash here? See, for example, why I don't want to put backslash here means minus doesn't have any special meaning in the regular expression. So I can just write minus itself. Then followed by minus, what should be there? See, digits. So I have to write digits. What is digit is already declared here. You can say digit means it's 0 or to 9. And this digit can be coming one or more number of time as we have said here. Plus means one or more number of time. So this is a pattern to match the negative number. So whenever it is matching a negative number, it should increment the negative number variable. So here we have a variable called negative number. So I'm incrementing. It is a C code. I hope you have understood until this. Now, so we found positive number and negative number. What is the next thing we have to find? I want to find the positive fraction as well as the negative fraction. That also I have to find it and I have to count it in the input from the input string. So how does a negative or positive, let us take positive fraction. How does a positive fraction looks like? So there are many ways. So I can write plus 54.97. I can also write 54.97. I can also write 0.97. Right? So these are the different ways I can write a positive fraction. So in this case, how will you write the regular expression? So first let us do for it. Plus. But already we have written for a positive number, right? Same thing will come for this. Because positive number can have plus or you can even skip the plus sign. So plus have a special meaning. So I put a escape sequence. Followed by the plus, you should say it can be there or it cannot be there. Followed by this plus, there should be what? Digit. So digit. And this digit should be repeated one or more number of times or zero or number. Shall I put plus? No. Why? Because here if you see in this place, there is no number. So sometimes even you can skip the numbers before the dot. So instead of putting plus here, what I'm going to do is I'm going to use star. What is the meaning of a star? The meaning of the star is it is a clean closure in regular expression. It is zero or more number of time. So here you can see there you can even miss the digit before a dot as well. So I am putting. So I have completed until this part before the dot. So followed by this, you have to put the dot. But you know, dot have a special meaning in regular expression to concatenate. So I have to escape from the special meaning. So I have to put backslash and dot. Followed by the dot, what will be there? It's easy then. You have digits. It can be any, at least one digit should be there for a dot. I cannot write a number 54 point. It should at least have 0 in it, right? So I have to, followed by this, I have to write digit. And that digits to come for one or more number of times, that is more important. So how will I write it? I'll say followed by the dot, there should be digit. And that digit should be coming for one or more number of times. So this is the pattern for finding the positive fraction. So if I find this pattern, you have to increment the positive fraction. Got it? Similarly, now we have to do it for negative fraction. So how the negative fraction should be looks like, it's compulsory start with minus and then you can write some numbers followed by 0.78. It can also written like minus 0.01. Right? So these are the options I have. So how will I write? Minus is compulsory. It doesn't have any meaning in the regular expression. So I don't want to put the escape sequence. Followed by I have digit. And this digit is not compulsory. You can have 0 because here there is no digit, right? In this place. So I can have 0 or more number of digit and then followed by a dot. Dot has a special meaning in regular expression. So put a backslash and a dot. Followed by I have digit. After the dot, there should be a digit. So plus. So this is a pattern or a regular expression to find the negative fraction. If you find this kind of pattern, immediately increment this variable negative fraction. So that is what increment. So after you do the translation rule, again you have to put the double percentage. So that's why there is a double percentage. So after the double percentage, what is the next thing? Auxiliary function. So here if you see, this is the part of the third part, that is the auxiliary function. So here I have written a main function of a C program because this is a combination of C, right? You write a .L program convert to C. So here you have the flavor of C as well inside the Lex program. So I have a main function of a C program followed by what is in. Already we learned some of the variables and functions used in the Lex program. So in is a a variable which is pointing to the input file. So here we are going to give the input in a text file called sam.txt, and I'm going to open it into the read mode. And in C, if you want to open a file, you can use a function fopen to open the file. So I have written it. And now y while x. What is y while x? It's the entry point. And then followed by, I'm going to print all these four variables output, right? So printf, which is in the C program, same thing. And now number of positive numbers and %d to specify the decimal value, close the double quotes, comma, positive number. Similarly, so positive number will be, the value present in the positive number will be displayed in this place. Similarly, all four variables are printed using the printf function of C program. And close the curly brace of the main function. And then you have, YY wrap. When you reach the end of the file, this function will be called. Since its return type is integer, return 1. So that's all. So when I give an input like this, it will count how many number of positive numbers, how many number of negative numbers, how many positive fractions, how many negative fractions, whichever is matching to this pattern, right? So this is this is how a Lex program looks like. So hope you have understood. If you didn't understand anything, please check it once again, the video, okay? So you will clearly understand. Thank you. God bless you.